Hello everyone. In the previous video we have seen that field oriented control of PMSM motor. In this video we are going to see how to integrate that MTPA control with the field oriented control for the same PMSM motor. So I have given that video link of FOC control in the description. You can see that and you can understand how the field oriented control is working. This is the speed control, and the output of speed control will be IQ reference or torque reference, which means IQ is proportional to torque value, and this is ID control. ID is proportional to flex reference, so we have to maintain that flex in the constant value. So we have given 0 as a ID reference. The output of ID controller will be VD, and output of IQ controller will be VQ. Those VD and VQ will be converted to ABC using inverse Park transformation and inverse Clark transformation. Those three reference sine wave is converted. Here I have implemented SV PWM generation. This is based on maximum minimum method, and those ABC reference will be converted into SV generation, and then that's space vector reference value is given to that PWM generator block. It's going to generate 6 PWM outputs by comparing those SV SV reference value and triangle value. So here I have given 10 kHz as a PWM frequency. So see here, so now I'm going to run with a 2500 RPM. So now the motor speed is 2500 RPM. It's working fine. So now I'm going to check with a 4000 RPM. Now it's not reaching 4000 RPM. So this is what I have explained in the previous video, FOC control, how to do FOC control, how it is working, how to run the motor beyond the base speed. This is what I have explained in that previous video. You can go there and see that. Now I will show that MTPA control. So in this MTPA control, we are going to generate a ID and IQ reference value using this MTPA. This is working based on lookup table value, and so the speed controller output will be the torque reference or IQ reference, and then it needs a one more input value, which is motor speed, and we have to give us a per unit value. And then it's going to give that ID and IQ reference value. This is connected with that ID controller and IQ controller. Other than that, everything will be same as field oriented control. So here I will show. I have given 4100 as a reference value, so it's reaching 4100 value. So we can able to run the motor beyond the base speed by using MTPA control. So if you are not implementing MTPA, we need to adjust that ID value in that negative side. So when we are that is we called as field weakening control. So when we are adjusting that ID value from the 0 to negative point, it will try to run the motor beyond the base speed. So in the field oriented control, we have given the same DC bus voltage as 600 voltage. That is the maximum voltage, maximum stator voltage. When we are giving maximum stator voltage, the motor can run till that base speed. So beyond the base speed, we don't have any parameters to adjust and to make the run motor beyond the base speed. So that is what MTPA control is explaining. So here till that base speed, it will work in that constant torque control. If you want to run the base speed beyond the run the motor beyond the base speed, we have to implement field oriented control. So when we are adjusting that ID reference in the negative side, it will try to run the motor beyond the base speed. So we call that constant power control. So that is what I have explained how to adjust that ID reference manually in the field oriented control. So here in the MTP, after implementing MTPA control, it's going to adjust that the ID reference and IQ reference automatically. So here in here you can see that, so this is ID reference, this is IQ reference. It will adjust automatically based on that torque reference and motor speed value. So that's it. Thank you. We'll meet soon with a new concept.